Today we are talking about kidney loop filtration and transfer carts. So what is a kidney loop filtration and transfer cart? Well, a kidney loop filtration and transfer cart is a mobile piece of equipment that suctions fluid like hydraulic oil, transmission fluid, engine oil, etc. out of a piece of equipment. It then pumps the fluid through a series of filters and then back into that piece of equipment. This process then repeats over and over again. You can use a pneumatic pump or an electric pump for this, depending on your application. The filters can range in micron rating, size, PSI. Some filter bases have a built-in bypass valve or a backflow prevention valve. You generally start with a large micron rated filter to capture the largest particulate, and then your final polish filter would be the smallest micron rated filter to capture your smallest particulate. There is also different types of filter materials to filter out certain contaminants, so you want to make sure that the filter is compatible with the fluid you are filtering. The cart can also be used to transfer fluid from one piece of equipment to another, or from a supply tank or a barrel to a piece of equipment. And so if your company, your piece of equipment needs to meet a certain ISO standard, if you send out an oil sample and you have it tested to see what the contaminants are, you can then figure out what type of filters you need to filter out those contaminants, what micron rating those filters need to be, etc. So there's basically two types of filters. The spin-on style with the rubber gasket. These are generally going to be lower pressure filters. Then you have the cartridge style filter element. So basically you can see it's a metal canister. Inside that metal canister is a filter element. And these can handle a much higher pressure. I believe the black one here that you're looking at on the right hand side of the screen is rated up upwards around 2000 psi. So here's an example of a kidney loop filtration and transfer cart. You can see the basic components and layout, both the side view and the back view on this one that I designed. So it has a quad filter rail. You can see it takes 4 spin-on style filters. And this one is a pneumatic diaphragm pump, and it has 2 hoses on the cart. So one is a suction hose, one is a discharge hose, and it has quick couplers on either ends of both hoses, as well as the inlet of the pump and the outlet of the filter rail. There's also a ball valve on the outlet of the filter rail to allow you to throttle the flow up or down as needed. And there are forklift pockets, so you can safely pick this cart up with a forklift and move it around. It also has casters and a push handle, so you can push it around like a shopping cart. And then I also installed 4 lifting eyes on the 4 top corners. So if you need to hook up a lifting sling, a chain sling to this, and say take it out to a remote job site on the back of your field service truck, you could do that. There's also a storage box where you can store miscellaneous fittings and quick couplers. And then there's a built-in drip pan. So when you change the filters, if any oil drips off anywhere, it'll be collected in that drip pan instead of making a mess on the ground. There's also a suction tube. Sometimes people call it a dip tube. So that's what you would stick down inside of a barrel or a tank to suck out of that particular barrel or tank. So here's another example. This is a pencil drawing I did a while back, more of a square-shaped, compact design. But again, these take the spin-on filters. You can see a J-hook to store your hoses on, a push handle, diaphragm pump, casters, forklift pockets, and it's basically rectangular tubing for the base and square tubing for the frame. This cart here that I designed and built is specifically for diesel fuel. So it's a 55-gallon drum. This is the front view. This is the back view. And you'll see circled in red is a three-way ball valve. So there's a three-way ball valve on the suction line and the discharge line. What the three-way ball valves allow you to do is to suck diesel fuel out of this cart through the filter back into the cart if you want to clean the fuel up, or you can suck fuel out of this cart through the filter to your piece of equipment, or you can suck the fuel out of your equipment into this tank. And then here's another pencil drawing I did a while back. This one has an electric pump that's compatible with diesel fuel. And you see the green is your discharge line with a dispensing nozzle. The red is your suction lines. And again, there's a dip tube and level gauges on the drum. And again, you can see the three-way ball valves. And this had a built-in containment pallet. So if there's any spills or leaks, it would be contained within the cart and not make a mess on the ground. So here's a close-up of what a three-way ball valve looks like. So again, depending on which direction you turn that handle, the flow is going to come either out the left or out the right side. And it's a good idea to have a desiccant style breather if you're going to be storing or transferring oil or fuel, etc., into a 55-gallon drum. The desiccant breather helps eliminate moisture from getting in and contaminating your fluid. So that would screw onto the top of your tank, still allow proper airflow, so that you can pump fluid out properly, but it's going to capture any moisture that's in the air. So you get clean, dry air going into your tank, not dirty air or moist air. And also, I'd recommend a service filter change gauge, but just make sure the PSI of the gauge is compatible with the pump pressure. Make sure your filters you're using are compatible with the pump pressure. For example, you don't want to have a high pressure pump pumping oil through a low pressure filter. You could actually explode that filter. So it's important that everything is compatible. The gauge, the lines, the filter, the pump, etc. And as far as how often you need to change the filters, again, if you see that needle move into the red zone, that's a good indicator. They also have higher PSI gauges that go up to a couple thousand PSI. So just get the appropriate one. But another rule of thumb, you could go by hours. So let's say every 50 hours or 250 hours, 500 hours, you can change your filter. It depends on your application. I hope this information helped. Please like, share, subscribe, and leave me a comment for future video topics you would like me to cover.